Chapter 15, question 49. Okay, 11 cis retinol is a molecule with the molecular formula C20H28O. The structure of this 11 cis retinol includes an aldehyde group, a cyclohexene ring, and a long aliphatic side chain. So there is a carbon-carbon double bond exists between the carbons numbered 11 and 12. Then they're asking which statement about 11 cis retinol could be correct. I'll try to rule out the impossible answer first. There's a double bond between carbon 11 and 12, and it is called cis, right? That means the same group, same type of atoms will be on the same side. So we look at this. Okay, same side, same side. Okay, A could be the answer. B is the opposite. This should be trans. D also opposite, so should be a trans. Now the possible answer is A or C. Now the only difference between A and C is how many double bond. A says 5, C says 6. So we have to draw the structure, propose a structure for this 11 cis retinol. First, I would draw the aldehyde group because it must be at the end of the chain. Okay, so this C20, I'm going to write the number to keep track. Make sure that, okay, I don't exceed the number. Now, there must be a cyclohexene ring. Okay, there will be an aldehyde group. So, let's draw this C, H, and O, right, for aldehyde. Now, I'll just put another carbon here. Now, I've used 2 carbon already. Then I'll put the cyclohexene here. Now, I do not know where should the hydrohexene, the cyclohexene be, but I just put anywhere because we are just proposing a structure for this retinol molecule. So altogether, I have 1, 2, 3, 4, 5, 6, 7, 8 carbon now. Now, I've used 8 already. 20 minus 8, I should have another 12 carbon. Okay. Now, I've used up 1 hydrogen, 2 hydrogen, 3 hydrogen, 4, 5, 6, 7, 8, 9 hydrogen. So, I have another 17. Use up the O, no more O. Okay. Now, if this is carbon number 1, 2, 3, 4, 5. I need 12 more carbon, yeah? Other than all this carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. The last carbon, okay, we have no choice. We must put a CH3. Because we must end with CH3. Okay, now I'm going to count from the right hand side. Number the carbon, yeah? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, 11, 12, 13, 14. Now between 11 and 12, there's a double bond. Okay, let's just put the double bond. Okay, try to adhere to the description as much as possible. Now, if there's a double bond here, can only be bonded to 2 hydrogen. Alright, now I've used up all the carbon. Okay, no more carbon. Now I use another 1, 2, 3, 4, 5. 5 hydrogen. So I now have another 12 hydrogen. Okay, now I do not know where will the double bond be, but to be safe, okay, I'm going to use a very simple method. Now here must be one H because it's already bonded to three things. Okay, I don't want to make this a double bond. Okay, use up another one. So now 11. Now I'm going to add hydrogen to only one side. Okay, because that will save my trouble for counting the double bond at the same time counting the hydrogen. So what I've just added is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 more. So left only with one more hydrogen. Okay, I can add one more hydrogen here because here all saturated, right? Okay, so no more hydrogen. Okay, it's time for us to add the double bond. Now this carbon is saturated. Okay, now this carbon and this carbon not saturated, I can add a double bond here. Okay, now each carbon 4 bonds. This carbon, okay, not saturated yet, add one more double bond. Okay, saturated, now these two, add one more. Okay, add one more. Okay, all carbon now has 4 bonds. It's time for us to count the number of CC double bond. 1. Okay, I shall use different color, maybe green. 1, 2, 3, 4, 5, and 6. Altogether 6 carbon-carbon double bond. So answer is C.